Hi, I'm Gareth Spence, and welcome to Tech Talk. Edge networks are under enormous pressure right now. Traffic from fiber broadband, 5G, and cloud services is growing fast, and traditional approaches to handling this traffic are proving costly and complex. To tell me how Adtran is solving this problem by driving 400G to the network edge, I'm joined by Matt Kennamore. Matt, why specifically are operators struggling now?
So we've seen a really big impact in traffic to the edge, right? And by what that means is users are using more and more bandwidth in their homes, which is driving the infrastructure cost of the OLTs to go up significantly, which is driving 100 gig ports to the edge in numbers that we have never seen before. So what operators are really needing are routers that are aggregating those 100 gig ports and putting them together into bundles and then exporting them out onto the network at 400 gig speeds and above. So what we're seeing is this large bandwidth shove all the way out to the edge, and there aren't a ton of solutions in the network or in the infrastructure available for them to choose from.
Can you highlight some of the specific technology used in this solution?
Absolutely. So what we see is customers are really concerned about being locked into their ecosystems, right? So we have a lot of customers that come to us and tell us, hey, we are looking to explore other technologies, but this other system that we have deployed has really locked us into this type of ecosystem. What we're able to do is to come in and say, by changing the way you're developing these networks and deploying these edge packet solutions, we're able to take that network that you've already got deployed and move it into an isolated EVPN, and then use these other routing technologies that we're able to do to deploy new technologies, new future-proof yourself, and to deploy those new segments into the network for you.
Do you have some of the units on display here at OFC?
I sure do, right? So these are a couple of our edge routers. These are designed to be paired with cabinet-type infrastructures all the way into the neighborhoods of customers. These two units, this is a 400 gig router, and this is a 100 gig router, and then we also actually have another 400 gig router that has many more ports on it, just not on display today. But these two routers are designed to be into cabinets all the way out into the neighborhoods, right? To take those large amounts of 100 gigs that we were already talking about, aggregate them together, and to put them onto a modern transport network that allows the users or the operators to be able to be completely flexible in terms of their approach on how they deploy services.
I understand that the SDX 8230 is incredibly compact. Can you talk a little bit about that?
Absolutely. So this top unit, this is the 400 gig 8230. This is a 1RU, and its cabinet depth, as you can see here, it's only about 19 inches deep, or about 300 millimeters. And it's designed with temperature hardened constraints and designed to go into these robust, rugged environments all the way to the edge of the network where these operators are facing the most struggles. They're designed to be paired with many types of different networks, from OLTs to active Ethernet to all of those type of infrastructure problems. And it solves a vast number of problems for those users.
How does it compare physically to what is already on the market?
So again, this is designed from the bottom up to be into those cabinets, right? A lot of what we've seen, the traditional router type vendors, they take their very, very large iron and try to compress it and squeeze it into that form factor, and they don't get, one, the same results, and two, they're typically over-engineered or over-costing, especially what they're needed at the edge of the network. These are not typical core routers, these are edge routers that are designed to augment your core routers. We're pushing on the same functionality, but at a smaller scale, which also reduces the operator's cost. These are kind of designed from the ground up to be the edge router solutions for our providers.
What does native 10G, 100G, and 400G support mean for operators planning their upgrades?
So that means that we can cover the entire breadth of what they have today, what they have this week, what they have going forward in the rest of this year, into next year, and then way into the future. Operators now, especially as they look at overbuilds or augmenting their networks, they want to make sure that, one, we're future-proof, right? Because doing any kind of network equipment change is a very costly and disruptive type of thing. But I want to put what I need in today, but I want to leave myself plenty of headroom available for tomorrow. That's where the 400 gig comes in really prevalent all the way out to the edge. Operators are typically only using multiples of 10 gigs lagged together, some 100 gigs that are partially filled in 20 or 30 gigs on 100 gig interfaces. But I want to make sure that I'm deploying those interfaces in mass so that I have plenty of headroom available, so as those speeds fill up, as those ports continue to fill up, that I have available to just turn on the next port, turn on the next service, and off I go.
I understand that Adtran's network operating system is also a key differentiator. Can you dive into that a little bit?
Absolutely. So what we have designed is we have taken the hardware and the software layers apart. Our hardware layers can be flexible, so we have our multiple different flavors of hardware that we can choose from, but the software is completely common across all of them. That gives the users a completely common experience in terms of configuration, operations, management, API access. All of those things are completely common, and the hardware changes based on what their needs are. At one site, I might only need an 800 gigabit fabric versus another site, I need a 2.4 terabit fabric. But the same operating system operates on both of those units with the exact same configurations, so the user gets a common experience, but they are able to cost optimize the edge, and that brings it back to the entire goal of this entire networking structure that we've designed is to cost optimize the edge routing portfolio.
How does the solution integrate with Adtran's wider product set?
That is a really great feature of all of the things that we're doing here. Because we are developing the routers, we're developing the plugs, we're developing the optical line system, we're developing the OLTs, everything together is able to integrate into a seamless experience for the operator. This gives the operator one choice, which is always a great thing, but also if they do choose multiple segments of our network, that they know that everything's tested together, that it works together, that everything is seamlessly integrated so that they get a very easy to deploy solution set that enables them to go rapid and with minimal amounts of user intervention.
Final question, for an operator evaluating this today, what's the bottom line?
The bottom line is we have a more economical way to reduce their costs at the edge routing network, to deploy robust, temperature-hardened, cabinet depth type routers all the way to the edge that enable the complete overlay or picking up of existing infrastructure and interlaying that into a modern packet-driven network.
Matt, thanks for joining me today.
Thank you.